Hey, welcome everybody to this Pionix webinar on ChargeBridge. As Marco already quickly said, we will have a Q&A session at the end of the webinar. So if you have any questions, please type them in the QA, and we will try to answer as many of them as possible at the end of the webinar. I'm Robert Tadeo, technology evangelist at Pionix, and I will do this webinar together with Cornelius Claus, our CTO. I will start with a very brief introduction of Pionix, who we are and what we do, and then we dive into the topic. So for people who don't know us, we are Pionix. We're a small startup from Germany. We're roughly 40 employees, and we started an amazing open source project called EVerest. EVerest is a open source charging station software stack. So any software that you need to run a charging station, all the different protocols are implemented in EVerest. On top of the open source project, we have a enterprise version, which we call Pionix BaseCamp. This provides additional APIs. You can get SLAs with us. We do long-term stable releases. We have a lot more documentation on this. We provide training. We provide updates also for Cyber Resilience Act. And next to that, we have something what we call Pionix Cloud, which is like a maintenance cloud for charger manufacturers. It's like a brief catch up, because if you didn't know us, we will mention Pionix BaseCamp a lot during this webinar. Agenda for today, we start with an introduction on high level and high and low level architectural split. This is also a bit of background to understand why ChargeBridge is such an amazing solution for building charging stations. Then we look at the challenges of developing custom charging station controllers. Then Cornelius will take over and present you ChargeBridge, all the details, and we go really in depth on what it is and what it can do and what makes this so amazing. Then we will look at our reference designs, and then we wrap up with comparing ChargeBridge and BaseCamp, what are they doing together, and then we're at the Q&A session at the end. If you look at a charging station, how do you build a charging station? What's in there? So if you haven't seen a charging station from the inside, there's a lot of stuff in there. This is an abstract, high-level DC charging station hardware. So there's a charging station controller here, and it connects to all this kind of different hardware that you need to make a charging station, as simple as a display, buttons. You might need an RFID reader or a payment terminal. It has a modem. It needs to talk to the car via a socket. It has relays. It might need an isolation monitor if it's a DC charger. It needs power modules. You need a power meter to measure the amount of energy going into the vehicle to do payments based on this. But if we dive a little bit deeper, if you really look at a charging station controller, you see a lot of charging stations more and more getting a split between high-level communication and low-level. You can almost take the analogy of the human body. The consciousness is Linux. This really runs all the thinking, all the smart stuff, all the communication towards all the different parts, where the low-level controller, the microcontroller, is more the reflexes of the human body. If you as human, you don't need to think about breathing, you don't need to think about your heart rate. This is all done automatically. And the microcontroller in a charging station controller is a bit the same. It takes care of all the safety. So the high-level controller, the Linux, doesn't need to worry about them. So the microcontroller keeps the charging station safe as reflexes keep your body safe. The high level runs all the protocols like 1578, OSVP. It has all the state machines, all the energy management. It does the updates of the charging station. Where the low level, this is functional safety. It might run a real-time operating system. It takes care of the PWM signal, the CP, MPP handling towards the car. This is really just the, as I said, it's almost like the reflexes of a human body compared to the human brain. And this is a bit needed to understand where ChargeBridge comes in. If you want to develop charging stations, you need a charging station controller. Now, there's two options. Either you make one yourself, or you buy something off the shelf. If you buy something off the shelf, you get a complete solution and you're up and running super fast. But if you want to make something yourself, you can buy some components and build something yourself, but it is a lot of work. Now, why would you? Why does it take a while to build your own charging station controller? It requires knowledge of electronics. It requires knowledge of manufacturing processes. It requires knowledge of how do you build a PCB, how you debug a PCB. You typically get involved way more different people in a company as well, because you need hardware developers, you need guys that understand electronics, you need guys that understand production of components, you need have supply chain guys that are able to buy the components you need for a controller. And then for each, if you build your first PCB, you go into iterations, because the first one, everybody that has ever developed a PCB, that first one, you're super happy if you get it up and running. You might need some soldering to get it working. And based on that, you do a fix on the layout, you fix the PCB schema, the schema files first, then you fix the layout, then you do a new prototype, and every sequence takes a couple of months to do that. So it is a longer time to market if you make your own charging station controller. I think I mentioned a lot of this already. So if you do this, we've seen this a lot. We've worked with a lot of manufacturers. What do we see going wrong? You need to port the firmware for the microcontroller. You need that low-level software that runs all the safety. We have an open version of that. You can port that, but that is work that needs to be done. You need to make a layout with the PLC chip that needs to be very accurate to get a very good signal-to-noise ratio. If you make mistakes there, signal-to-noise ratio isn't good, and some vehicles might not communicate with you. You need to get the PPCP circuit correct. You need to, so a lot of stuff can go wrong during the development of a charging station controller, and we think we can simplify this. Now, this is where ChargeBridge comes in. Cornelius, you want to take over here?
Sure. If you go to the next slide, I don't think I can click on them. Yeah, thanks. So as Robert already pointed out, developing your own charging controller is like a relatively long and complex problem. Yet we found that in most of the projects we work with, it's still the only real solution, because like ready-made controllers that you can buy, they're always like wrong. You can never build a controller that fits all the different applications and all the different architectures. So in the end, most projects will actually build their own, even though it's a relatively hard and long process. So our focus is on how can we speed that up quite a bit to make it possible to have all the flexibility of a custom-made controller without having all the hassle of doing it. So the first and most important point, I think, is taking all of the complexity that you have in such a charging controller and move into a small reusable module. And that reduces your actual controller board to more like a baseboard or a carrier board than a full controller, which also simplifies the hardware design then. To speed that up even further, we will provide like reference design that are open schematics and open layouts. And you can just use them and modify them a bit or steal ideas from it, just to make sure you're very quick with like pre-tested designs. We also want to simplify the software development, so you don't really want to go down and writing firmware for the safety MCU, for example, or write drivers for it for the Linux side. It should really just work all out of the box when your hardware is there. We'd like to decouple the Linux board from the actual charging hardware. I'll go into that a bit more in a minute. And we want to de-risk the certification, because we also saw that a lot of the time is usually eaten up at the very end of the development cycle when you're basically done. but then failing in certification in some minor things and actually going back to step one and redesigning some portions of the PCB. On the next slide, a little bit more on what ChargeBridge actually is. So ChargeBridge is a small module that basically contains all the functionality that is needed to communicate with the vehicle, as well as all other components that you typically have that belong to the charging port. So that's safety relays, isolation monitors, the power modules, power metering, everything that kind of belongs to one port, one charging port, can be connected to the ChargeBridge. It also contains like all the safety functions. I'll go to that in a minute. And then all of that information basically is wired up to the high-level Linux port by a single Ethernet or USB connection. And on the Linux side, you can run our BaseCamp stack with ISO 15118 and OCPP and everything that's high level. But you're completely independent now with how to choose the Linux port here. So it can be an embedded ARM, it can be an industrial PC, it can even be your laptop. It doesn't matter because it doesn't need any specialized interfaces anymore. So you don't need that SPI to connect to the Qualcomm chip, as well as an interrupt line that you need to configure in the device tree to actually make it an interrupt. And all of these hassle, you don't need that anymore. You can just run any Linux on any Linux computer and connect it by Ethernet or USB to the rest of the charging port. So your carrier board that you're designing, or the charge controller, is simplified to more or less being just a breakout board that wires all the wires from ChargeBridge to like proper physical connectors that you need in your application and give it like the physical form factor that you need to mount it in your case. So a little bit on the technical specifications. So the ChargeBridge CCS is designed for both AC and DC charging. It comes in a relatively small footprint of just 46 by 22 millimeters on an M2 connector. And besides the Ethernet and USB uplink to the host that we just saw, it also has just a single 3.3 volt power supply input. So that's quite important because, for example, the minus 12 volts and the plus 12 volts that you need for CP, or some of the voltages that you need for PLC, they all generated locally on the board. So you don't need to worry about that at all. It basically has two functional blocks. The first one, I always call it the complete charging port front end. So it's basically everything that you need to wire it up to a charging cable. So that's CP, PP, PLC modem, that's control for the relays as well, that switch the power for the charging cable. It's temperature sensing of the plug. It's controlling the cooling system of, if it's a cooled cable, for example, everything that's required to connect a charging cable to it, basically. That's one portion of the functionality. And the second portion is just generic input-output. So it gives you all the buses that you typically need to talk to external components, such as power meters and isolation monitors and power supplies. So it gives you CAN and RS485 and UART and GPIOs. And then all of that. So let's go a bit more into detail on the first part again. The charging port front end comes with a lot of integrated safety functions as well. And all of the safety functions are implemented locally on the module. So the remote Linux is not safety critical at all. It basically doesn't matter if it even is switched on or not. The whole module is pre-certified to functional safety according to industrial standards. That's IEC 61508. And it controls the relays directly. That's part of the safety functions, of course, with a feedback input to monitor the relay health and detect if they are welded, for example, and if they're operating properly. It implements the control pilot as well as proximity pilot according to IEC and SAE standards for North America and Europe. And it also implements all the safety functionality that is required by the standards and all the timings, for example. It features over temperature shutdown as well. So for DC, that's typically PT1000 sensors in the plug. For AC, it's more like NTCs and PTCs typically. It has over voltage protection feature as well. It's an especially interesting one because it's relatively new. It was introduced in the IEC 6185123 in the 2023 edition. And it's a quite hard requirement because it requires you to switch off in certain lower voltage conditions within 9 milliseconds of detection time. And that's typically missing in many of the designs and ready-made controllers that are currently out there because they're still done after the 2014 edition of the norm. But it's already included here. Besides like a normal stop input for a regular stop button, it also has an emergency stop input. That's interesting. You can connect, for example, an external emergency stop button or a door sensor if somebody opens the case, or the isolation monitor or some RCD, or basically any external device that needs to be able to switch off the port in an emergency. And if that happens, there's also an emergency output, which is triggered by all the external sources as well as all the internal safety features. And you can connect that, for example, to an emergency input on a power supply. So some power supplies support that. Or for CAN-based power supplies, it can also send a specialized CAN frame to switch off the power supplies before it actually forces the relays to open. So even in an emergency, it actually takes care that in almost all cases, if that's technically feasible, the current is ramped down before the relays are actually open, just to protect them and extend their lifetime. So on the second block of functionality, all the generic interfaces, so how does that actually work? If you look on the right, you have all the buses like CAN and RS485 and UART, and also the PLC communication, and all of them are actually transparently tunneled through the Ethernet or USB to the Linux board. And in Linux, they show up just as virtual ports. So for the CAN, you just get a regular CAN device in Linux. It's a socket CAN device. You can use it with standard tools like CAN dump and IP to configure it. And if you send a package to that CAN bus, it was just transparently piped through the Ethernet, and it comes out at the physical CAN bus at the ChargeBridge module. And the same is true for all the other interfaces. So for PLC communication, you actually get a local TAP device actually that's just tunneled through the physical PLC modem. And this is all with the PLC. It's already interesting because it gives you it removes the length limit, right? You can have 100 meters of Ethernet easily, while PLC is typically limited to like 5 meters or maybe 10. So why do we do all these tunneling of those interfaces as well, and not just connect them directly? Well, one part of the answer we already looked at, that was the separation of the Linux compute versus the charging port. So that's one part of the answer, but there's actually a lot more aspects to it on why we do this. So on the next slide. One of the reasons is it removes a lot of the complex wiring. So especially in DC, many of the chargers, they are full of like a lot of wires and a lot of long wires especially. So ChargeBridge gives you the possibility to actually build sub-assemblies of everything that belongs to one charging port and wire it like locally with small wires, like short wires, or even like put it on a single PCB or so, and then connect it all to a compute that's somewhere else with a single wire essentially. And having these sub-assemblies not only simplifies production because you have those sub-assemblies that you can individually test. It's not, you can not only test when the full charger is assembled, but you can test those sub-assemblies separately. It also actually reduces the number of spare parts that you need. So it also simplifies maintenance and repair in the end. So a third argument, and probably the biggest one, is it enables a whole lot of different architectures with the same solution. So traditionally, you always had the split between, let's say, an integrated controller architecture. You have one charging station with 1 or 2 ports typically. It comes with a controller inside, and the power supplies, everything is like in there. And then there's all the different kind of satellite architectures where you typically have, I don't know, 20, 50, maybe even 100 charging ports scattered over a parking lot with a centralized control logic and maybe even centralized power supply. And with ChargeBridge, finally, all those architectures are the same from a solution perspective, because if you use the Ethernet, you can just wire up 50 or 100 to the same Linux computer. There is actually no need to have one Ethernet port in Linux for one ChargeBridge module. You can just use standard Ethernet switching methods to connect as many as you want. And this means you can build all the architectures you like. You can build all of this in one case. And if it's like really close together, you can use USB. If it's a bit further away, just use the Ethernet within one charging station. But if you have a satellite architecture with 100 on a parking lot and centralized compute, you can run the exact same hardware and also the exact same software, but just making the Ethernet wires longer. And this will still give you like all the local buses. Even if it's 100 meters away, you will have like the local CAN bus from that charging station in your Linux. So next slide. As a slight variant, of course, just to show the actual network topology doesn't matter at all. You can, of course, also use a daisy changed Ethernet topology. That just doesn't matter. So yeah, last big picture from my side, at least, is forward compatibility. That's also a quite big one that you won't find in most of the other solutions. This whole ChargeBridge journey actually starts with CCS, but other standards will follow. So we will build MCS and GPT, CHAdeMO and ChowChi, and possibly also other standards or variations of standards that are coming up in like pin-compatible modules. So the interesting fact here is really that everything that is like specific for the charging standard itself is actually on the module. So this enables you to build carrier or controller boards using the ChargeBridge that are completely independent of the charging standard. So imagine you build your charging controller and you can actually you can change from like CCS to MCS basically by plugging in another ChargeBridge module and connecting a different charging cable. And like the rest of the PCB can remain the same. And the same way you can switch to CHAdeMO or ChowChi in the future. And yeah, with that, I'd like to hand over to Robert again.
You are mute, Robert.
Hey, thanks, Cornelius, and sorry for being muted. So as Cornelius told, ChargeBridge really speeds up your development. It simplifies a charging station controller design. You can make a prototype of your charge station controller faster. You can reduce the amount of cycles because it just becomes a carrier board. It includes all the safety functionality that you would need in the charging station. It includes all the CPP pre-processing for CCS. You don't need to develop or port the low-level firmware anymore. All of this comes included in ChargeBridge. It comes with a license for the software, and it comes with lifetime support for that license, for that software. It also includes even, and Cornelius didn't mention it yet, it includes a license for BaseCamp. So you also already get a license for BaseCamp to use BaseCamp in your charging station. Cornelius already quickly mentioned them, reference designs. Cornelius has made already a couple of reference designs to showcase what can be done with ChargeBridge. And these will also become open hardware. So we will make the schematics and the scheme and the layout files and the BOM files all available open hardware. So you can use that as your starting point to build a charging station controller based on a ChargeBridge. Now, the first one is a DC charging port. So this is this controls any external relays with 24 volt power supply. Yeah, this one is 600 kilowatt. If you have bigger relays, you could control even more. It has the over voltage protection integrated on the controller itself. So you just wire that up directly. You don't need an external component. and it also integrates with the Sensata isolation monitor. That also means you don't need to wire up a isolation monitor cable. This is really connected to the bottom of the carrier board, reducing the amount of wires even more. We will see that with the next reference design. This is a smaller reference design, so this is a 150 kilowatt reference design. This has integrated relays. You can see them here on top of the PCB. This is also the overvoltage protection already integrated, and so as all the power on this design goes through the board, the overvoltage protection is also inside the board itself. You don't need to wire that up. And as I already said, this also includes the Sensata insulation monitor, and you can see it here due to the aspect ratio that the it's underneath the board itself, so it directly plugs into this open hardware carrier board, making it really tiny, really small. And what you can also see really well, this also has an example for doing daisy chaining. So you have dual Ethernet ports, one to link up to the Linux and the other one to daisy chain to the second port, third port, whatever you want to do. You provide DC power into this board, and you have the Ethernet cable going to Linux, and you have the charging cable, and you're done. Yeah, you might need to add a power meter if you want to measure the amount of energy going into the vehicle. But for the rest, most of this is all on board. Of course, we can also do AC. So fully integrated board, all the components on here to make a single port AC charging socket. So imagine this one has all the daisy chaining. You can build easily a big charging plaza, one Linux controller. You hook up power to this board. You hook up the cable, you hook up Ethernet, and you have your charging port. That even supports 1578-20 because it has the PLC chip on there. Yeah, the only thing you need to add again is the power meter, the energy meter, because that is not on the board itself. And it's also not something you want to do on the board because that needs to be certified. Now, if you want to do a lot of development, this might also help. We designed a breakout board. You can easily hook up any device, play around, try stuff out before you start building your own carrier board, maybe, just to simplify things. All these boards will become open hardware. We will also provide them if you need a sample, if you need one of them just to have a starting point, we will provide those as samples as well. But we won't do the mass production of these kind of boards because that is not what we're aiming for. Yeah, already Cornelius mentioned shortly already, one of the advantages of using ChargeBridge with the single Ethernet or USB cable, it super simplifies your development. You can just hook up one of the carrier boards with ChargeBridge, plug it into your laptop, and run BaseCamp from your development laptop. You don't need to cross-compile again. So as soon as you have something you want to fix, you don't need to cross-compile. You can just spin up BaseCamp on your laptop. So it's super fast to test new stuff, debug things. Your developers that need to work on a UI, for example, can already start working with a one port to integrate the UI even without any official end hardware that you are developing, because they can already use like a reference board to start their development. Yeah, that was it on the reference designs. Now, looking a bit on BaseCamp. Is ChargeBridge going to replace BaseCamp? Nope. It's more like the perfect combination. BaseCamp provides you all the brains, all the software stacks you need to run a charging station. But what it doesn't have is the low-level firmware. You can write it yourself. There's an open reference design for it, but we really simplify making your own charge station controller with ChargeBridge. So there's a perfect companion. And as I already said, ChargeBridge comes with a BaseCamp license, so you have everything you need to get started. Again, for comparison, ChargeBridge provides you all the low-level functionality, all the low-level protocol stuff you need to make a charging station, where BaseCamp provides you all the high-level stuff. So all the OSFP 1.6.2.0.1.2.1, 15.11a-2-20, AC, DC, bidirectional is all here. DIN spec is here. Energy management, over-the-air updates. BaseCamp provides additional stable API support for TPM modules. So all of that is combining these two, it's everything you need to make a charging station. How does ChargeBridge compare to something off the shelf, like take EVerest, a board that is available from Vitec that you can buy that runs BaseCamp as well. EVerest is a dual socket charging station controller. So this is an off-the-shelf board that contains both a Linux SoM and basically, if you would abstract this a bit, two ChargeBridges. So within the green boxes here, these are roughly the components and connectors that would come from ChargeBridge and a carrier board. So it is one board that does everything at once, but ChargeBridge is like a part of this. We're talking to Vitec. They are already starting to work on a new version of the EVerest, and that one will also contain ChargeBridge. How does ChargeBridge compare to PLC stems? There's a lot of companies that make PLC stems, basically a small PCB that contains the greenfied chip. The simplest version of it is just the greenfied chip. So you only get the Qualcomm chip, and you can add that to your own charging station controller. So how did we end up getting these? Basically, there was no way to buy these chips early days. The manufacturer of these chips, they just didn't want to work with everybody. So there were only a handful of companies that were able to source these chips and put them on PCBs and resell them again. Now, the simplest is just the PLC chip, the greenfied chip. The more advanced are greenfied chips that also do the CP and PP circuitry, but they also include 1511.8 stack. So they combine a little bit of both, but you still need a Linux SoM to run the rest of the software that you then need to do yourself, where with ChargeBridge, you have BaseCamp that does all the software stack, and it has all the safety functionality firmware, which isn't in the PLC stem. So you still need to write that, which is then not in the real-time part. So you need two microcontrollers to run this and a Linux to run the main software. So ChargeBridge really puts everything in one module to add all the functionality you need to be a perfect companion to something high level like to something like BaseCamp. What's the release plan? We launched ChargeBridge the 7th of May at Power to Drive. We've planned this webinar, so you are all part of this today. First samples will go to customers end of August or early August, and we expect to do mass production in December. So if you're thinking about or interested in starting working with ChargeBridge, please reach out so we can provide you with samples in August. That should give you ample of time to start mass production in December, because it gives you a couple of months to develop, test, debug before you are going into production. So we expect it should be fine for all of our potential customers. If you want to get in contact and learn more, scan the QR code, send an email to contact@pionix.com, and we will get back to you as soon as possible. So wrapping up before we go to the QA, ChargeBridge is an all-in-one hardware module. So you get one module that does all the low-level communication to the car. It does all the connectivity you need on one charging socket. It tunnels all of that over Ethernet to the Linux SoM. It comes with a BaseCamp license that perfectly works directly with the ChargeBridge. It has all the safety and functional safety firmware here. You get the software, you get lifetime updates for this software. You only need to include this on a carrier board to make this in a charge port, hook that up to any Linux single board computer, either via Ethernet or locally via USB. Especially if you make a carrier board that is for one charging station, you might use USB. If it's internally, if you go to satellite setup, that's where Ethernet probably is a better solution. And all in all, ChargeBridge is the perfect partner for BaseCamp. And that brings us to the Q&A. Let's see, we have some questions. We have some votes on questions. Let's see who has the highest votes. I see somebody. Arun. So one ChargeBridge module supports one charging gun, is it? Yes, I think so. Yeah.
Yeah,
ChargeBridge
exactly.
is a ChargeBridge. You need one ChargeBridge module for each charging socket, charging gun, whatever term you use. It doesn't do more. You need one per charging socket.
But I think important to know, you can attach multiple ChargeBridge on one board. So the idea is to have it really, really minimal. And if you want to have one controller board with 3 dispensers, you would put 3 ChargeBridges on it, 1 Linux SoM, and then you can still scale this up. So don't has to be satellite architecture. It can be.
Yep. Correct, Marco. Thanks. And the next question, will you deliver the slides at the end of the webinar? Yeah, we can upload the slides to, let me think where we put it, but we can send them to everybody who subscribed to this webinar. And we will also make the recording available. So as soon as the recording is uploaded, you will also get the link to the video. And we will send it to everybody on the mailing list, because there might be people that had not the opportunity to join but did register. Next question. Does every ChargeBridge module have to sit on its own Linux-based carrier board, or can several modules be bridged via Ethernet USB and managed by a single central CPU? As we already said, you need one ChargeBridge per charging port. You can have a lot of the charging ports for one Linux SoM. It depends a bit on how much, how strong the microprocessor is you have on your Linux single board computer, and it depends a bit on what else it is doing. EVerest doesn't take a lot, or BaseCamp doesn't take a lot to run. We have it up and running on older architectural single core ARMs. We never advise that, but it does work. But even if you take a dual core, you have a big display with video on it, you might need more processing power. So how many of the charge bridges you can connect depends a bit on what else that processor is doing.
And maybe to extend to that, because that also, I think, covers another question from why Ethernet and USB. The USB is primarily used on if you have that on a single PCB. So if you make like one PCB with like 2, 3, or 4 or whatever number of charge bridges, you probably don't want to do like Ethernet routing and Ethernet switching within the PCB. So then you can just use USB and USB hubs. That's a lot simpler and cheaper. The moment you have longer wires, you will probably want to use the Ethernet, as it gives you a lot more stability over longer wires.
Thank you, Cornelius. Next one on the list is, do we have IEC 61508 documentation, and which SIL level do you support, Cornelius?
So documentation will be released with the hardware, so it's not available yet, but there will be a safety manual, for example, that you need to follow to integrate this, to actually have all the safety certifications. The SIL level, currently we're targeting SIL 0. Actually, the 6155851 does not require any specific level at all at the moment. We're looking into like SIL 2 as well. This is still under consideration whether it will be SIL 1 or SIL 2.
Thank you. What is the cost of ChargeBridge for CCS? And how many can you connect to one card? I think the first question first, how much does ChargeBridge cost? And if you want to know cost, please reach out to us, because it greatly depends on the volume of you want to buy. And part of that is that the ChargeBridge license is really depending on the charging speed you're going to use it for and the volume you're buying per year. And that greatly influences the price of ChargeBridge itself, because you get a BaseCamp license with it. So please reach out to us with your use case, how you want to use it, and then we can give you a price for that. Your second part is, how many guns can you connect to one card? As already mentioned, one charge bridge is for one charging socket. Next question, how do you integrate displays on the satellites?
Yeah, that's also an interesting question. So yeah, I mean, compute on the ChargeBridge is quite limited. So if you have only the ChargeBridge locally, there are some displays that are actually serially connected. Those can be used actually even via the transparent tunnel. So it all depends on what type of display you actually need in the satellite. So we see typically two applications. One is if you just want to have a lot of charging ports and it's for a company or it's like semi-public setting, typically you either have no display at all, or let's say a very limited one. It's like a small display that just shows like the charging state or maybe QR code for payment or something like that. But it's relatively simple. Those can actually be connected serially directly to the ChargeBridge and then controlled from the Linux. If you need, like, let's say, full-blown 40-inch 3D animation advertisement thingy, then probably you can't get around having another Linux locally in the dispensers.
Yeah, and I can almost envision that then you're almost running EVerest even locally. You have one ChargeBridge, one Linux SoM running EVerest plus the advertisement on each satellite instead of one central version of EVerest, because it just becomes one charging station because of the display needing that processing power anyhow, and you want to keep that locally.
You can do either one, and the beauty is that you can do all these arrangements and all these architectures with the same hardware pieces.
No, you have the option.
And I think the good point here is that EVerest or BaseCamp doesn't require a dedicated CPU, so you can mix all your advertisement screen things onto the same CPU. So you're not ending up with a charging station where you have one CPU for the display, one for remote management, another CPU for charging. No, you can share that. EVerest is so modular and so resource friendly, that's not an issue.
Thanks for the explanation, Marco. Is ChargeBridge for end products or only for development? The operation temperature range is between -40 to 85.
Yeah, so standard temperature range will be -20 to +85. There is the possibility to have -40 in an extended temperature range for a little bit higher price because the -40 components are just a little bit more expensive, but that's possible if needed. But let's say standard temperature range is usually -20 because within the charger, if you don't have like super extreme conditions, typically it won't get a lot colder than -20 because all the components heat up as well.
Thank you. Does ChargeBridge support for Wi-Fi communication for OPP charge and or SIE J3105? I think that's for bus charging typically. That would probably require a different ChargeBridge if we want to support the up-charge pantograph style chargers.
Yeah, or let's say the Wi-Fi part is with the central Linux. We, however, in EVerest and BaseCamp do not have like support for those protocols yet. There is work going on in the open source community, so feel free to join the working groups. There's some effort going on there to implement those things.
Thanks. Next question. The OSPP sits on which card? OSPP is part of the Linux SoM, so BaseCamp. BaseCamp contains OSPP 1.6, 2.0.1, and 2.1. That is not part of ChargeBridge itself. And the next one we already had. Does on the ChargeBridge run Linux OS as well, or is it a real-time operating system?
It actually runs a real-time operating system. It's actually ThreadX that runs on the ChargeBridge.
Do you currently support AC discharge? BaseCamp and EVerest don't support AC bidirectional yet. That is on the roadmap for EVerest. As soon as that is supported, then also ChargeBridge will support it because technically ChargeBridge is transparent for this. You just need to have the communication, the high-level communication that needs to work here.
Yeah, the basis for AC bidirectional are already in EVerest actually, but it's like super early, I would say, and not very well tested because also there are hardly any EVs available that support it. So I'd say it's in a very, very early stage.
Thanks. Next question. So the split means you don't need real-time Linux. I think that's an early question. So the split between high level and low level control in the charging station controller. Yes, the low level controller is real time, where the high level is running any Linux version. So you don't need a real time version of Linux on the Linux SoM or single board computer. Next question, why Ethernet and USB? Basically, we wanted to give both options.
Yeah, I think we already covered that. The USB is for like if it's on a single PCB, and the Ethernet if it's on multiple parts.
Yeah. And ChargeBridge has the I/O to do that, so we wanted to keep both options open. Otherwise, we would have had a ChargeBridge for Ethernet and one for USB.
Yeah. But maybe just to clarify, you cannot use both at the same time. So it's either USB or Ethernet.
There is a limit to the pins we have there. What kind of security is used between ChargeBridge and the Linux? What about crypto fragility?
So yeah, you can choose between encrypted and unencrypted. Basically, the first release for the prototypes will be unencrypted, but for production, it will support DTLS. So it's actually a UDP connection. Everything is routed through a single UDP connection. And there's a possibility to use DTLS on UDP to actually encrypt this. And if you want to, also authorize this, so you can actually do something like MDTLS if needed. That's especially useful if you run this like over a parking spot, so if you have the wires outside of your charging station. While if it's on the same PCB, you probably go for unencrypted because of the easier setup.
Yeah, and also it's harder to hack into it. Something if it's on the PCB itself, you're already in the housing of the charging station. You have all the problems as well. Next question: what is the latency of tunneling COM via Ethernet USB?
Yeah, that's also an interesting
applications
one.
have demands for low response times.
That's one reason why it's not automotive, so we don't do the EV side here. For charging stations, you typically don't have those very strict requirements, so the latency is definitely not under a millisecond. That's super hard even with normal Linux, even if everything is locally connected. So you can expect more like less than 10 milliseconds to be realistic over Ethernet.
Next question: isolation monitoring device is available in your DC fast charger design. The isolation monitor itself is not in the design. It is designed to work with the Sensata, this reference design. So if you take this reference design, you can buy the Sensata isolation monitor and connect it to the carrier board. The design of the Sensata, we don't have that even, and we don't allow to share that even, so that you have to ask them. Next question: can we update the firmware of ChargeBridge from the Linux MPU /BaseCamp?
Yes, simple answer.
Yes, and we need to be able to do that anyhow.
Yeah.
Is the Ethernet link used to communicate with ChargeBridge actually a GreenPhi interface? I understand there's an onboard STM32 as well. Does the STM32 communicate via the same GreenPhi Ethernet interface, or does it handle the business independently?
So the Ethernet endpoint, if you look from the Linux, the Ethernet is connected to the STM32 internally, and then actually it talks to the GreenPhi chip via SPI. So you only have a single Ethernet connection to the STM.
Thanks. Ooh, can ChargeBridge be tested on a general purpose single board computer with M2?
No, it's just the mechanical form factor and connector. It's not the pin out of a standard M2.
I would probably also advise not to put it on a general single board computer, because I'm not sure what would happen there.
But just reusing the connectors because they are like really cheap, well tested, and easily available. But yeah, as I said, it's not the pin out of the standard M2.
And then let's see where we are with the questions. Are you envisioning MID certification.
MID certification is for metering. Which one? I don't see the question.
Yeah, it just popped up.
No, the actual power metering is externally. So you can connect an MID certified meter, for example, via RS485 Modbus to it. But we don't do any metering on the ChargeBridge itself.
If somebody would want to develop a controller board with MID on the board itself and certify that, that's of course an option. You could take the reference design, take that in, add MID, there's a reference design from some of the component suppliers, add that all into a single board and go through all the certification yourself. But we don't have that planned.
I think so. Maybe extend on that. Analog Devices is doing a reference design, which I think could be certified then if you go take that into production for metering. That already works with EVerest. I think there's already a driver released, or at least soon to be released. And the good thing is all the meterings we mentioned more or less directly connect to the EVerest Linux side. So the ChargeBridge is just forwarding or tunneling the CAN bus, the Modbus, the Ethernet, whatever it is. So, but it's not a ChargeBridge topic. This directly ends up on the Linux. Potentially tunneled through the ChargeBridge.
Thanks. I think the last question, unless something else pops up, can we integrate ChargeBridge also with an IMD from vendor via Modbus serial?
Yeah, it's a very common setup. So if you use the RS485 Modbus, you can, for example, use the ISO-CHAR 425. That's fully supported and well tested. We have that in a lot of setups.
Yeah, I think the main reason we don't have it in the reference designs is because we love the idea of not having to cable a isolation monitor to something with additional wires and additional cabling, which, yeah.
So Robert, I have actually way more questions open. I'm not sure if you implicitly answered them.
Yeah, I'm using the popular order now, and somehow they pop up and some move. I will just go over the list again.
The popular order is not updating. You have to click on some other order and then back on popular. I think the next top one is possible to promise secure firmware update.
Yep, it's a secure firmware update. There's even A/B channels on the microcontroller, so you can actually update while it's working, and then everything can be verified and signature can be verified and everything. And then if it's ready, for example, after a charging session finishes, it can actually reboot into the new slot.
Thanks. Next one is the Ethernet link used to communicate with ChargeBridge actually a GreenPhi interface? And then there's an onboard STM32 as well. Does the STM32 communicate via the same GreenPhi Ethernet interface, or does it handle its business independently?
I think we covered that already and just didn't mark it. So there's a single Ethernet to the STM32, and that connects to the PLC then.
Okay, then let me see what is else open.
Will some of the carrier boards be open sourced? All of the carrier boards will be open sourced.
Yeah, just not the ChargeBridge module itself, but all the carrier boards we design will be open sourced.
And we already had that one.
Covered as well, but the updates.
AC discharge we already had. The splits, yes.
I think we covered all of them.
I think so too.
Yep.
Yes.
The slides, we will send out the slides afterwards. So please expect them in your inbox, as well as a link to their recording, maybe with a bit more delay.
And with that, thanks everybody for attending. Thanks for all the questions. We have a next webinar coming up. It has been on the slide already for a while. We will do a EVerest webinar on the 8th of July, because we have a really old one and we really want to do a new one with the latest status of EVerest. So I hope to see a lot of you on the 8th of July. We will explain EVerest a bit more in depth. Hey, thanks everybody for joining, and have a good day, good evening.
Thank you.
Thank you.
Bye-bye.
Bye.